I'm Anil Kumar. In this video, I'll discuss about open and closed interval, and we'll keep absolute maximum or global maximum minimum as a context for this video. Now, this video is for my subscriber who wants to really understand how open and closed interval plays a role in finding global maximum and minimum. Now, let's begin with understanding what is open interval and what is closed interval. So let me just sketch a line here to begin with, and from there we'll start our discussion. So on this plane, let us say we have a line which is kind of like this. So for simplicity, I'm drawing it through origin. Simple equation for this line could be y equals to 2x, for example, right? So that's the line which we are considering. Now at present, what is the domain of the line? Well, the domain is all real numbers. We know x belongs to real numbers, and the range is also all real numbers. We will say that there is no bound. The line can go from minus infinity to plus infinity. The value also can go from minus infinity to plus infinity, correct? But if I restrict, and if I am only interested in a portion of this line, for example, if I say let my boundary be from 0 to, let's say, some value 4, right? 0 to 4. In that case, all of a sudden, we are talking about a fixed interval, which is bound from both the sides. Let me call the point on the left as A and on the right as B. So what happens now? The line has now become a line segment. Do you see that? This line segment has a boundary that the x value is greater than equal to 0 and is less than equal to 4. So when we have this kind of a situation, we say it is closed interval, right? So we can say this as x is greater than equal to 0, less than equal to 4. Another way of writing the same thing is with these square brackets 0 to 4. So square brackets really give you the closed interval concept. So if it is a closed interval, you'll find square brackets both sides. So if you have closed interval, the other way could be inequality, where we are working with sign like greater than equal to, less than equal to. So equal to is always included with the boundary condition. That means we know which the two ends are. You can treat it as a line segment. So I hope that makes the concept clear. Now, as soon as I restrict myself to line segment AB, then what happens? Now let's write down domain and range for line segment AB. So we are talking now about a segment which is confined on both the sides, right? So for this segment, now what is the domain? Domain for this segment is from 0 to 4. And what is range? Y is from 0 to 8, because I have taken y equals to 2x. So what we see here is that all of a sudden a line, when it is bound by from the left and the right side, we call that becomes a closed interval. Now as soon as I do closed interval, do we have absolute maximum or global maximum value here? Yes, we do. As you can see here, the line segment has a maximum value of 8 and also a minimum value of 0, correct? So those are called absolute maximum and minimum values. So I hope now we have linked up the two things. That is, if we have something continuous, line is continuous, right? If we have something continuous which is bound from both the sides, represented by these square brackets, then we also have absolute maximum and absolute minimum. At times in books we also use the word global, right? So global maximum and global minimum. So you understand this concept, correct? So that is what it is. Open interval really is that the boundaries are not set, right? So if I say if I write this inequality in a different way, for example, if I say x is greater than 0 and is less than, let's say, 4. Now I have not included equal to sign. That means x could be very, very close to 0. We are saying x belongs to real numbers, okay? Where x belongs to real numbers. Correct? If I say integers, you know what integers are between 0 and 4, right? So it has to be x belongs to real numbers. In that context, in this open interval, we'll first write this as 0 not included. That means 0 is not included and 4 not included. We are not really sure how close can we go to 0 or how close could we go to 4. Like we could be at 3.99. It could be 3.999. So this number is not definite. And therefore, we are not sure what is going to be our maximum. It may not be 8. We know it is not 8. But is it 7.9, 7.99 or what? So in open interval, we will not have global maximum or minimum, since we are not sure what those points are. But in a closed interval, we will always have global absolute maximum and minimum, right? So at times we refer to this also as an extreme value theorem, right? So we'll also come across, we are not discussing this here, but extreme value theorem is on this base. Where in addition to closed interval, we have another condition which is continuous, right? So those are two conditions which ensure that you will always have absolute maximum and absolute minimum, or global maximum and global minimum. Now let's take 3 examples here. So here, when we are trying to write a graph or draw a graph, in that case, these closed ends, so these are circles filled in. So these circles are filled in. Do you see that? So that gives you closed interval. So for the first graph, what is the domain? Domain is x belongs to -3 to +3 with square brackets. That is the closed interval. Is it okay? In the second case, we do have a domain. I'm assuming this to be at 2, right? We do have a domain which is kind of defined. So in this case, we do have x belongs to the domain which is from 1 to 2.3. Okay, but there is a discontinuity. This is a jump discontinuity. So the function here is not continuous. Is it okay? So it's kind of different. It still has a closed interval, but the function is not continuous. In the third case, we have open interval. So in this open interval, I'll write x belongs to, so this bracket should not be closed, it should not be a square bracket, from -4 to 5. Do you see that? Now that is open. Whenever we are showing open interval on a graph, it is a circle which is not filled in. Right? So that is how you have to show open interval in a graph. Now, let's look into the maximum minimum values also. Now, in the first case, we have a closed interval, continuous function. So it has a couple of things in it. First, closed and then continuous. So if you have this condition, then we'll always have absolute maximum, which you can see here, a value of 4, and absolute minimum, a value of half. Do you see that? So we have absolute maximum and absolute minimum value whenever you will have a closed interval. Now here, we can actually give range of this function also. We can write range of this function as, let me write on this side, let's say Ry is, let me write interval notation, closed interval, since we know the value, it is from half to, let me give this value as, let's say 6, from half to 6. Is it okay? Now that is the range, that absolute or global minimum to global maximum gives you range when we have closed interval, correct? Now in this particular case, we do have a range, and here the range is, you can say y belongs to, since these are closed at this point, so the lowest absolute minimum or global minimum is defined at 2.3. However, the maximum is not defined. It is close to 3 with an open interval. Do you see that bracket? So that is how we are going to denote range for such cases. The last example here minimum is not defined. The minimum is open. So in this case, range will be y belongs to from 0 to, where 0 is not within square brackets, to 3. We know 3 is the maximum value, so I'm closing it with square brackets. So whenever you have to show open intervals, in that case, open intervals, you have to use signs like this. And on a number line, as we are showing on a line, it could be shown with open circles, right? So open circle like this will show this. This is how open interval will be shown on a line. Closed interval on a line will be shown with filled in circles. That becomes closed, including the two ends, as we did for segment A and B, correct? Or we did in these graphs by filling them up, right? This is open, this is closed. So that is how you can understand open and closed interval. Now, from the notes of my subscriber, I've taken this example. The example is, let f of x be equal to 2x cubed minus 9x squared plus 12x plus 6. Discuss global maximum and minimum of f of x in closed interval 0 to 2 and open interval 1 to 3. Find domain and range of f of x for corresponding intervals separately. Is that okay? I'd like you to pause the video, solve this question, and well, to solve this question, you should know derivatives, right? So we use first and second derivatives in this particular case to sketch the graph, find the equation, and then write domain range as well as absolute value of maximum and minimum, or local value of maximum and minimum as per our case, correct? So we'll take up now. Meanwhile, you can always pause the video, copy the question, solve, and then look into my suggestions. But I hope the concept of open and closed interval is clear, and now we are going to connect it with global maximum and minimum. Now we will discuss open and closed interval with respect to absolute maximum minimum, also being referred to as global maximum minimum, with the help of our example. F of x equals to 2x cubed minus 9x squared plus 12x plus 6. We'll discuss maximum and minimum of f of x in closed interval 0 to 2 and open interval 1 to 3. We'll also find domain and range of the given function for corresponding intervals. Now before I do that, I have actually to sketch the function, right? So that's the first part. So first we will sketch the function. To sketch, we need to find first and second derivatives. So the function given to us is f of x equals to 2x cubed minus 9x squared plus 12x plus 6. Let's find the first derivative, which is 9 times 2, 6 x squared minus 18 x, 3 times 2, 6, right, plus 12. So that is the first derivative. To find critical numbers, what should we do? So critical numbers means the derivative should be equal to 0. So let's equate this to 0. So we get 0 equals to 6x squared minus 18x plus 12. You can always take 6 common. So we get x squared minus 3x plus 2. That is a quadratic equation. 6 times product of 2, sum of minus 3, x minus 2 times x minus 1. So we get two critical numbers, right? So our critical numbers here are x equals to 2 and x equals to 1. Okay, now let us analyze these critical numbers, whether we have maximum or minimum. Easy way to do it is that it represents a parabola opening upwards, right? So what we can do here is we can just make a parabola opening upwards. So let's say this is the parabola which opens up, and as you can see, the points here are zeros 1 and 2, right? So these are your zeros. So what you observe here is clearly that the function is actually increasing from infinity to 1, right? Because this is positive. We are analyzing what? We are analyzing first derivative. Correct? So if first derivative is positive, that means it is increasing, right? So here the function is increasing. This is increasing function. Here the function is decreasing. Since it is negative, and after 2, it is again positive, so it is increasing. And that results into maximum at 1. So we have maximum value here, and we have a minimum value there. Is it okay? So what we can do is find what is f of 1 and what is f of 2, so that we can get these values. So let's find what is f of 1 equals to. F of 1 means just substitute 1 here. So what we get? We get 2 minus 9 plus 12 plus 6. I'm substituting 1 here. 1 cube is 1, 1 square, all ones, right? So we get 2 minus 9 plus 12 plus 6, which is equal to how much? 2 minus 9 minus 7. Well, let's add all these plus things first. 18, 20, 20 take away 9 is 11, right? So it is 11. And f of 2 is how much? So 2 cube is 8. 8 times 2 is 16. Okay. Minus 4 times 9, 36. Plus 2 times 12, 24. You can always use calculator for all this, correct? Okay. So 24 plus 6 is 30. 30 plus 16, 46. Take away 36 is 10. Okay. So we get f of 2 at 10. So we have maximum value of 11, minimum of 10 at the points 1 and 2. Okay, so we have done half of it. Now let's try to find the point of inflection also. That's kind of critical, right? And then we will answer the questions. Okay. To find point of inflection, what should I do? I have to find the second derivative, correct? So first derivative is right there. We are going to use this to find second derivative. So second derivative is 6 times 2, 12, 12x minus 18, right? So 12x minus 18 gives us, you can take 6 common. So we have 2x minus 3. Now for point of inflection, that should be 0, right? So we can equate this to second derivative should be equal to 0. That is our critical number for point of inflection where concavity changes, correct? So equating that, what do we get? We get 0 equals to 6 times 2x plus 3, and clearly at x equals to 3 over 2, this is minus, sorry. At x equals to 3 over 2, which is 1.5, we do have a point of inflection, correct? So now we are in a position to sketch our graph, correct? Okay, sir. Those of you who don't understand this derivative portion, bear with me. I did all this to sketch the graph, but then we can together discuss maximum, minimum, domain, and range. Think as if not the function, but the graph is given to you, okay? So I'll use this space to sketch the graph. Okay, most of my values are positive, so let me go here. Right. Let's sketch the function. Okay, so the function is a cubic function, so we'll go like this. Okay. I really don't know what y-intercept is, but we can always find it, right? So it's good to find. Since we're talking about intervals 0 to 2, well, let's start our discussion, and then gradually we'll find all these values. Okay, so now we'll begin with our solution. We are doing the first part now. We'll discuss maximum and minimum in closed interval and in open interval, right? So let's begin with the closed interval. So first is closed interval, which is between 0 to 2. So that means we are interested in this point 0, and at 2 we have minimum, right? So this point 2. We know this point is at 1. The value here for 1 is 11. For 2 we found this to be 10. Correct. So that's the graph. Now in the closed interval, all these points are included. Let me highlight my curve in the interval we are interested, 0 to 2. That means from here, right, to this place. So that is the curve which we are now working on. Right? And now within this closed interval, what do you think is maximum, what is minimum? So we have to check. We know the maximum seems to be okay, so we say, well, the global maximum or absolute maximum is at 111, right? Is at 111. So at x equals to 1, the value is 11. Is it okay? So I'm not writing separately. At 1, the value is 11. How about global minimum? Now, global minimum is right there, right, at 0. So what we should do? So that clearly indicates that whenever you're working in closed interval, you have to find values at both these intervals and at critical number. We already found values at critical number. We need to find value also at 0. So let's substitute f of 0. If you substitute 0 here, clearly you get 6. So this value is 6 for us. Correct? So you can see from here that absolute minimum is actually at x equals to 0, the value is 6. So I'm writing 0 and 6 here. That is a coordinate point. Okay, this is not an interval. Okay. Now I hope that point is clear. So we have answered all this thing. And within this interval, we have absolute minimum at x equals to 0. Not that. That is a local minimum. Is it okay? This is a local maximum, but also absolute maximum in this interval, not in the whole interval. That point is higher. Do you see that? And here we have a much lower point. So when you restrict the domain, we do get absolute maximum and minimum. Correct? Now let's write down domain and range for this function. So what is a domain? Domain is given to you. Domain is x belongs to real numbers, where so these are different nomenclatures. So I'm purposely using inequality just to show you that closed interval could also be given in terms of inequality. That is the interval given within the brackets. So it is between 0 to 2 we are talking about. So greater than equal to, right? And as far as the range is concerned, we can say y belongs to real numbers. Okay, yeah, this is the set of values. Y belongs to real number, where y is from 6 to 11. Do you see that? From 6 to 11. Both included. Both included. Now that is very important. So we have done domain, range, and maximum minimum for closed interval. Now let's consider open interval. Open interval 1 to 3. That means 1 is not included and even 3 is not included. So let's get to 3 also. So first thing is, let me find what is the value of the function at 3. So I'll substitute 3 here. So I get this as, let's use the calculator, right? Faster. So we have 2 times 3 cube minus 9 times 3 square plus 12 times 3, and then we'll do plus 6 equals to 15. So we get a value of 15 at 3. Just substitute 3 in your equation, get the value. So what we get here is that somewhere more than 11, let's say this value is at 3. On this side it is 15. Okay, that is what it is. Now since this is open interval, I'm making a circle here. Do you see? Not filled in, a circle here. So we are working from the interval 1 to 3. So this circle to that circle. So this is the part of the graph we are working with now. So all the answers will be based on not including the point 111, not including the point 315, but everything in between. That is what we mean when we talk about open interval. Is that clear? This is closed interval. Okay, now I'd like you to pause the video, answer all these questions. So first, of course, is maximum and minimum. Do we have absolute maximum? No, we don't. We don't know what is closest to 15. Do you get my point? So we don't have absolute maximum, but we have absolute minimum, which is at this point, right? So absolute minimum is there, which is at 2, and the value is 10. Perfect. So that is your absolute minimum, but we do not have absolute maximum. That's very clear. Is it okay? Because those points are not included. And now let's talk about domain and range. So let me write the domain in as given. So we have domain as between 1 and 3, of course, both not included. And as far as the range is concerned, what is the range? We know the absolute minimum, which is included, is the value 10, right? So we'll have the lower limit as 10. However, the upper is not included. It approaches 15. It approaches 15, not included. So that is how you're going to write it, not the square bracket. Do you understand? So I hope with this, the concept of closed and open interval is clear. How absolute maximum or global maximum minimum are related. If we have a closed interval, then we will surely have both global maximum and minimum, but we are not sure about having global maximum minimum when the interval is open. You could have one of them. You may have none of them. All options are open in that case. Do you get the point, right? Always use square brackets for closed intervals, never for open interval. Is it okay? That is another very important thing to notice. And well, these are the things. I think you should go through it. And I hope you find it interesting and useful. Feel free to make your suggestions, share and like my videos if you like. Thanks for watching and all the best.